Hello, everyone, and welcome to Calc Chats 23. This is where we're going to be talking about integration by parts. This is my third time doing this video because I recorded the wrong screen twice, and so we're doing a lot of writing. So this is the third time I'm doing it. So we're gonna have a good time. All right. So integration by parts. We need to use integration by parts when we're given two functions that cannot be split up by substitution. And it's basically our integral equivalent of the product rule. So if I look at trying to figure out the derivative of e to the x times x squared, I need to use the product rule because I have two different functions. And so I take the integral of the first times, the first times the derivative of the second plus the second times the derivative of the first. So this is kind of a similar idea down here with this integration by parts. And this is our rule. So we take the integral of u times dv equals uv minus the integral of v times du. And so u and dv, there's two separate functions, and we're going to talk about how to pick which is which. So I'm asked to evaluate the integral of x times cosine x dx. And I see my two separate functions pretty clearly, x and cosine, but I need to figure out which one is my u and which one is my dv. So I'm going to look over onto this next page. And so to pick your u and dv, there's this handy acronym which is called ILEAT. And so we have not learned about these ones yet, but basically these I, L, and A are kind of your better U functions to pick, and T and E are your better DV functions to pick. A can really go either way, but it's probably a better U if you have it than trig or exponents. And so we got our inverse trig, our logarithmic, algebraic / polynomials, and then our trig functions and exponentials. And so the ones on the bottom, again, are better for DV. Ones on the top are better for U. So I'm going to pick my u is equal to x, and my dv is equal to cosine x dx. And so in my original rule, I take the integral of u dv equals uv minus the integral v du. All right. So my du is 1 dx. And my v is I have to integrate the cosine x, so the integral of cosine x is just sine x. So then now that I have all of these terms, I can plug them into my handy-dandy formula. So I want to take my u, which is x times v sine x, minus the integral of sine x times du, which is just 1 dx. So I end up with x times sine x minus, and then this I actually know. I know the integral of sine x. I know that that is cosine x. And then don't forget that plus c whenever we have to integrate a definite integral. I'm sorry, the integral of sine x should be negative cosine x, so that ends up being positive cosine x. So this is our final answer. So now that was a pretty easy one, but sometimes we're going to have to use kind of a repeat of the integration by parts. And so this tabular method will work with any type of integration by parts that's going to kind of bottom out, and we'll talk about kind of what that means. But basically, we can pick our u and our dv as normal, and then I'm going to make a giant chart. And so on the u side, I'm going to take derivatives, and on the dv side, I'm going to take anti-derivatives. So I'm going to write x squared. Derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. And so this is what I mean when I say kind of bottoms out. The derivative eventually turns to 0. So this is way that we can use when the derivative eventually turns to 0. When it doesn't, we're going to have that separate conversation in the next example. And so I did my derivatives. Now I need to do my antiderivatives. So the antiderivative of e to the x is e to the x, and I just keep going down. So if I notice this side doesn't bottom out, but that's fine because all I really need to go to 0 is my u, which is why I'm taking the derivative of it. So when I use the tabular method, I just draw lines until diagonally across until I get to my 0. So once I get to my 0, I can stop. And then each line alternates a sign. And so my integral, my final integral is equal to x squared times e to the x minus 2x e to the x. So I'm just taking these and multiplying them. And then plus 2 e to the x, and then plus c. So this tabular, you could do this the regular way, but you would have to do it multiple times. And so this tabular method is super nice just to kind of keep track of things. And you can even do this with the example prior. It'll just be really quick, but this is just a nice way of keeping track of things. So our DIY problem today, the integral of x cubed sine x dx. And so I'd like you to try to set this up using probably the tabular method will be the easier one. So take a minute, pause it, and try it on your own. So these are what I picked for my u and dv. This is my chart. And if you scroll all the way down here, this is all one answer. So negative x cubed cosine x plus 3x squared sine x plus 6x cosine x minus sine x, 6 sine x plus c. The past two examples that we've talked about, we did have our u kind of bottom out, and the derivative turned to 0, and so it almost disappeared. This is an example of when our u does not turn to 0. All right, so if I think back to my I late, I don't have an inverse, an ln, or an algebraic in either of these. And so this is going to be one where we have to kind of cycle through it a few times before we get the final answer. I'm going to pick my u to be e to the x, and I'm going to pick my dv to be cosine x dx. So again, first I need to find du, and that's e to the x dx. Then I find v, which the integral of cosine x is just sine x. And if we remember our handy dandy formula, the integral of u dv is uv minus the integral of v du. And so I'm going to be very particular in the way I write this because you're going to kind of see how it cycles back. So the integral of e to the x cosine x dx equals e to the x times sine x minus the integral of sine x e to the x dx. And so here I see I have to use u, e to the x, and dv sine x again. I have to go through it. You can't even read that. Then my du again, e to the x, and my v, the integral of sine, is negative cosine. So I'm going to go through it again. So the integral e to the x cosine x dx equals e to the x sine x minus, and then I'm just going to write this integral on a separate line, minus u v minus the integral of v du. So when I simplify this, all right. So if we notice, I have the integral of e to the x cosine x on both sides of my equal sign. So what I'm going to do is, now that I've kind of cycled back through, I'm going to add this integral to both sides. We should all have dx's. So I get 2 integral e to the x cosine x dx equals e to the x sine x plus e to the x cosine x. And now to solve for this integral, all I need to do is divide by 2. So I get that this integral is equal to e to the x sine x plus e to the x cosine x divided by 2. And can't forget that plus c. So we can wait to add the plus c onto the end. That way it just doesn't really get in our way. So this is your final answer for this problem. So this is a lot of tough stuff, but please come to class with any questions that you have, and make sure that you like and subscribe.